Hi everyone, this is Mrs. Van Horn and this is the first lesson recording for IM2 Distance Learning Week 7. We are going to be exploring volumes of 3D solids today. As usual, we started off with doing some warm-up problems. You are supposed to find surface area of each figure and round your answers to the nearest hundreds if necessary. So please pause the video now and copy this down and solve this yourself. Some announcements. This week's schedule is slightly different because of Memorial Day weekend. And so if you're watching this video ahead and you're from period 4, don't forget to turn up for the last 10 minutes of the class. That's at 1:50 on Friday to take the quiz, the weekly quiz. And if you're a senior, this is your last math lesson at Prospect. And so congratulations and good luck with next year, whatever you're doing. And you are also excused from the mini project that I am just about to explain. So the final mini project that you are going to be doing is on surface area and volume. This is in place of your homework and next week's quiz, which means this is your homework for this week and you will not have a quiz on volume next week. So to explain this further, I am going to go to Google Classroom. So if I go to Google Classroom, under classwork, under week 7, you're going to find DL week 7 final mini project, surface area and volume. So if you open it up, you'll find more information about it. It says watch the lesson recording A first. This is what you're listening to right now. And complete the assignment and upload the work as an attachment. If you are working with a partner, you only need to submit one copy with the members clearly labeled, and this project is in lieu of the homework this week and next week's quiz. You can print out the document or you can work on a binder paper as usual. So what are we doing? You are using the skills that you've learned in finding the surface area and volume to figure out the surface area and volume of some real object. You're also developing some estimation skills and comparing that to your actual calculations. You should look at the sample problem that I've solved for you to show you what I do expect. And it says you may work with another person, just one more person from the same class. However, the contribution from each person must be clearly visible. So for example, if you are solving this portion of the problem and your name is Susan Peck, okay, then you might put SP on the area that you've done the problem. If your partner's name is John Smith, you might put John JS next to the problem that you solved or you checked together. So it needs to be really clearly visible which is your contribution, and it should be equally divided. And I do not want you to divide it up as in like one person does all the calculations and the other person does more drawing or anything like that. Both of you need to have practice on calculations. So I want your partnership to be really bouncing back and forth ideas to make sure that you really think this is the correct answer. It should not be divide and conquer. Everybody should be doing the calculations yourself. As far as grading goes, it will be worth 20 points of the homework as usual, as well as 20 points from the quiz. And it will be graded on completion. That's going to be worth 5 points. Clear communication of thinking process, 5 points. Accuracy, that means no or minimal errors in calculations. And authenticity, is it your authentic work or did you copy it from somebody else? And choice of units and rounding, and I will explain this a little bit more in a little while. And equal and effective partner contribution if applicable. So if you're working as a partner, this will be taken into account as well. It's going to be due on the finals day, and for 4th period I am open to giving you extensions. However, Monday 6th, next Monday, will be the best time to turn it in by, so that you do not have this hanging over you. Really, this project should not take you more than really 1.5 hours or 2 hours max. Okay, So, and then period 5, it is due on the Tuesday, on the finals day at 11:55 p.m. So if I click on this document, it's going to open up the document and show me what the document is all about. Let's wait for it to load. Okay, here we go. Okay, so you are finding the surface area and volume of 6 different items. The first one I have done for you to demonstrate what I do expect. The first column is the item description. In this case, it's the Coke can. Okay, so for each of the item, you need to write what does surface area represent, what does volume represent. So surface area in this case is how much aluminum I need to make the can. The volume represents how much of soda is inside the can, right? And then diagram, you do need to draw your own diagram and label with H and R and S or whatever letter that you think is appropriate to calculate the surface area and volume. For dimensions, you have 2 different dimensions you'll be writing. One is going to be rough estimate and the other one is going to be actual. That's either going to be measured or from your research. So rough estimate was when I just think about can of Coke or can of soda. From my memory, I clearly defined where my source was. It was from my memory. I think radius will be maybe about 1.5 inches. So you need to have an idea as to how big is an inch, how big is a centimeters, how big is a meter. Those are all important skills. I am thinking height might be 6 inches. And then I am going to use that value to calculate my surface area and volume. And do not forget to use units at the end, okay, to include units. And for pi, I am okay with, for estimation, that you use 3. For the actual calculation, 3 is not going to be accurate enough. So you either need to use 3.14, or actually better will be to use the calculator value, which has many more digits than just 3.14. So for the actual, I measured it. So some of these problems, you're not going to be actually able to measure it, but you're going to research it. And if you've done the research on it and found the dimensions, then you're going to write down the link where you found your information right here. Okay, and then for the so in this case, I measured the diameter of the can. So then I calculated the radius, and the height was 4.75. So it was my estimation, and the actual was a little bit off, but that's not too far off. So I'm good with that. And surface area, using the actual measurement, I found the surface area and the volume. And you could even do a quick comparison of the volume and actual volume versus your estimation. Okay, so you have 6 items. The first item is a box of Cheerios or any other cereal box. So if you are choosing any box, you need to specify the size as well, so as well as the brand, so that I know which box you're talking about. And then you can estimate the dimensions, and you can research it, or you can actually measure it yourself. It's up to you. So again, it does not have to be Cheerios box. It can be any cereal box. The next item that you're going to be measuring is the leaning tower of pizza. For these, to calculate surface area and volume, assume that the tower is upright and not leaning. It gets a little bit more complicated to figure out the volume and surface area when it is leaning. So just use the dimensions from the research as well as your estimation. And figure that out. Okay, assume that this is not leaning for the sake of calculation. The third one is 2-person triangular tent. Again, you will do some research or maybe measure it yourself if you have one of those. So you can go to Dick's Sporting Goods and find some triangular tent and get their dimensions from there. But you do need to fill all of this as well as clearly mark where you're getting the information from. The fourth is Pyramid at the Louvre Museum in Paris, France, which is pretty cool. So you are going to have to do some research, and again, write down your source here as well as do all the calculations. And then fifth is this Guinness world record ice cream cone. And then finally, it is a sphere of your choice. I need to fix this document, but it's a sphere of your choice. So you could pick a basketball, you could pick a tennis ball, you could pick something bigger, you could pick an orange, a whole lot of different things that you are in contact with in everyday life. So, and depending on what it is that you've chosen, you are going to have to figure out the appropriate unit that you should measure in. So this applies for everything. If you're measuring something, you need to figure out what is the most appropriate measurement. So say if I am measuring the box of Cheerio, I would not use meters because that would be too big, or I would not use yards. But maybe the best one would be inches or centimeters, and then from there you can do your calculations. So again, I will be grading on the rounding and your appropriate choice of units. Okay, so that is part of the grading, so make sure you take that into account, please. Okay, so back to my slides. During the finals week, then what are we doing? Well, I'll be available at our regular class Google Meet time to provide the last minute support for anybody who's finishing up the project, or to offer optional quiz, makeup, or retake. The finals scheduled to be Monday for period 4, 1 to 2, and for period 5, 1 to 2 on Tuesdays. I am also offering the optional quiz to cover any material covered during the distance learning, and its score, if higher, will replace your lowest quiz from the distance learning. But it's really important that you let me know if you're interested in doing this so that I can prepare, because I'm not really sure if anyone is interested or not. So if you're interested, please email me to let me know that you are interested in doing the makeup or to retake. Then I can prepare accordingly. Okay, so here are the warm-up problems. Let me go through the answers first. Okay, so with this, to calculate the surface area, you had to figure out this dimension, right? So if you knew the 6 and 8, what is the hypotenuse? Because knowing that this is a right angle, this has to be 10 miles. So then you use that to calculate the surface area. I am just going to go through the answers first, and then I will show you my worked out solutions more in detail. Okay, so here we go. So we first calculated the hypotenuse of this right angle triangle to be 10 miles, and then surface area is going to be 2 base triangles plus the rectangles, the bottom rectangle plus this left rectangle and this right rectangle, and I've shown you the work there, and you should have gotten 336 miles squared. Then for the second problem, again, surface area is going to be the base rectangle area plus 2 skinny triangles, and then 2 wider triangles here, which comes to 9.7 plus 2 times half times 7 times 11, 7 times 11 for the skinny triangle, and then for the wide triangle is going to be 9 times 10.6 times half, because it's a triangle and we have 2 of those, and so it comes to 235.4 yards squared. Number 3, surface area is going to be the 2 circles, top and bottom of the cylinder, plus the side rectangle, and you substitute the values and you should have gotten 1,357.17 inches square. And then the last question in number 4 is, here we go, the surface area of this cone is going to be the base circle plus this sector of a circle, and the sector of the circle area is going to be given by pi r h, where h is the slant height. So plug in the values and you should have gotten 91.42 kilometers squared as your final answer. And this is the end of the first lesson recording.